So we saw that if we rapidly expand a gas in a piston cylinder by removing a 1 kilogram block from the piston, we saw that the amount of work that's exerted by the system in the forward case is not equal to the amount of work that's received by the system in the backwards case, right? And so what we're going to do now is we're going to kind of evaluate another system that's very similar to the first one. Right? So let's now consider case 2. All right? And so in this system, we're again going to look at a vertical piston cylinder in which the gas is initially in state 1 at volume 1 equals 0.1 meters cubed. But instead of one block being on the piston, one 1 kilogram block, instead what we're going to have is 2 half kilogram blocks on it. Okay? Alright? And so it's the same mass on top of the piston in the initial state. And so MB, the block total, is still 1 kilogram. Okay? Alright, and so we have this system initially where we have 2 half kilogram blocks on it. And what we're going to do is we're going to remove one block at a time. So we remove one block. So removing one block, that allows the gas to expand a little bit. To some volume. That's intermediate between 0.1 meter cubed and 1 meter cubed. And then, after we let the system get to that second volume, we're then going to remove the other block. Okay? And by doing that, it allows the system, allows the gas to expand all the way to volume 3, which is 1 meter cubed. Okay? And so now that we have the second case in which we kind of broke up our block into 2 equal masses, now what we want to do is we want to calculate the total amount of work exerted by the system as the gas expands from state 1 to 2 and then from state 2 to 3. And then we also want to compare it to the backwards case, where we go from state 3 to state 2 and then back to state 1. To calculate the work, we could do a similar analysis that we did in case 1. And so when the system is expanding from state 1 to state 2, we could once again split up this process into 2 separate steps, where first we just look at how the pressure changes, and then second we look at how the volume changes. Alright? And so by performing a similar analysis that we did in the previous case, we could estimate that the initial pressure for the system in state 1 is just equal to this. This is AP. And then the pressure after we remove the first block is this. To 1/2 of the block mass. Okay? And that's because from step 1 to step 2, we only remove one of these 1/2 kilogram blocks. And so now the pressure is reduced by this factor. Okay? And then similarly, when we change the volume in the system, we could calculate the work associated with that change. And that work, as the system is going to be expanding from state 1 to state 2, it's going to be acting against pressure 2. And so the work from state 1 to state 2, that expansion, is going to be pressure 2 times V2 minus V1. Okay? And then, when we go from step 2, or state 2, to state 3, we could also split this up into 2 steps, where we first change the pressure, and then we change the volume. And as such, if we do the same sort of force balance that we did during the case 1 expansion, we would see that the new pressure is just this. Okay? Because we now removed the second block. And if we calculate the work going from state 2 to state 3, we would see that it's just P3 V3 minus V2. Okay? Alright? And so we could visualize this once again by using that PV diagram. Where this is pressure, this is volume, and our system is going to be passing through 3 different pressures. And also 3 different volumes. Okay? And so if I draw the line that describes the ideal gas here in black, should be more of a curved line. Let me fix this up so it matches a little bit better. Okay. When the system is expanded from volume 1 to volume 2, what we first did is we first changed that pressure, and then we changed the volume. Okay? And so the work associated with that process is this. And then in the second step, we first change the pressure to P3, and then we change the volume. Okay? And so the work of the total process, if we go from 1 to 3 entirely, is just going to be the sum of the work going from states 1 to 2 and then states 2 to 3. And So we write it out like this. And I'm going to move this to the left so we have a little bit more room. We could actually plug in for the pressures that we calculated. PATM plus MP. And we're going to rearrange the equation slightly. Plus 1/2 M block G over AP V2 minus V1. Okay? Alright, and so this is what the total work ends up being. And the thing I want to remind you, at least with the premise of this problem, this V3 here, this is equal to 1 meter cubed, and this is equal to 0.1 meter cubed. Alright, and so in this case, our V3 is 1 meter cubed, and that's what we called V2 in case 1. And anyhow, the reason I bring that up is because if we take a look at this term in the work equation, where this is 1 meter cubed minus 0.1 meter cubed, this is the same exact term that we got when we calculated the work in case 1. Alright? And so what this equation is telling us is that if we expand the gas in 2 steps, we're actually able not only to extract the same work that we extracted when we expanded the gas in 1 step, we also get a little bit extra work that we extract as well, right? And so we get back that case 1 work plus a little bit extra. And we could also see that visually here, because now if we take the area under the curve from each of our expansions, we get a little bit more area that we cover. Okay? And so if we even consider the opposite case as well, if we go from state 3 to state 2, then state 1, it would look something like this. So when we're going to from state 3 to state 2, we would be decreasing the volume like this, and then from state 2 to state 1, we'd be decreasing the volume like this. And so then the work required for the backwards compression, it would still be more than the work required for the forward process, but now that area is a little bit closer, the magnitude of that area is a little bit closer to what we got for the magnitude of the forward case. And so to write this, at least in words, to summarize the point I'm trying to make, is that by removing the blocks piecewise, so instead of doing it all in 1 step, if we split it into 2 steps, what we get is that more work is transferred from the gas to the surroundings. Okay? So we're able to extract more work from this irreversible process. And speaking of irreversible, the backwards process, if we go from 3 to 1, the magnitude of that is still greater than the magnitude of the forward case, but that difference, or it's smaller than the forward process, but the difference between the two is much smaller than what we saw in case 1. And essentially, by removing the mass in a piecewise manner, what happens is we get a smaller energy penalty to run or reverse the process.